Hello and welcome to the Pre-Calculus Podcast. I am your host. We are moving on to episode 3, which is dealing with hyperbolas. Okay, so hyperbolas, which is another conic section that we're going over. So we've talked about parabolas, circles, ellipses. Now we're talking about hyperbola, which all conic sections are based on the idea of taking a cone or multiple cones and cutting them in some way to get either a parabola or a circle or an ellipse. And so hyperbolas, if you have two cones stacked up, and then what you would do is if you cut this segment off of each, what would the shape be? And the shape ends up looking something like this, which is our hyperbolas. Okay, so if you kind of cut it down vertically, then you cut through both cones, you end up with this. So a hyperbola is what a hyperbola is the set of all points that's the absolute value of the difference of the distance from the foci when the foci is constant. So if we go from, so if you remember, an ellipse is where we take 2 points and then let's say we find another point right here. That point is a part of it because if we add this and this together, they equal the same as if it was here. So those would be the exact same. Okay. Hyperbola is different where it's taking a point, okay, and it's not adding those two together, it's subtracting them. So it's finding the difference of them. So this difference is equal to that difference. And as you notice, if let's say I take this point here, so if let's say this is the distance I'm looking for, if I take a point here, assuming these are equal, that difference is 0. So that point wouldn't be a part of my hyperbola. Okay, so this one we're taking the difference of them instead of adding them. The midpoint is again the center of the two foci. So once we have our two foci, okay, the middle point of it is our center, which is going to be where our h comma k is located. So there's two ways that these can open. One way is open horizontally, and the other way is open vertically. So if it's open horizontally, we have x squared over a squared minus y squared over b squared is equal to 1. And there's stuff going on. And so what you notice here that's different than the previous ones is that we're subtracting these fractions instead of adding them. So it's because we're subtracting them, that's how we get our hyperbola. Okay, the vertices are going to be located at negative a0 and a0, again, if the hk is 0, so if it's centered at the origin. Your foci is located at negative c0 and c0, again, if it's opening horizontally. That's if the x squared is first. And you notice the c is a little different. In a hyperbola, you're dealing with a squared plus b squared, so you're basically doing the Pythagorean theorem for it. Okay. And the last part is our equation for the asymptotes. These formulas have asymptotes. Okay? And with them being asymptotes, what end up happening is that we're able to find what the equations are. And that's going to help us with some of our graphing. Okay. Next is if it's open vertically. So if it's opening up and down, and if it's opening up and down, you notice the only difference between this one and the previous one is that the y is now first. So if the y comes before the x and the x is being subtracted, you have it open vertically. Okay, if the x is first, it's horizontal, y is first, it's vertical. Okay, and our equation is just switching everything. So now it's the y values that are changing, not the x values that are changing. Okay, all right. So this would be an example of how you could go through and you could graph a parabola that's centered at, or a hyperbola that's centered at the origin. What we have is that we make a box, we draw lines in our box, and then we have our parabola from there. Okay, so that's how we can go through and we can graph this figure. So let's do an example of this. So let's say we have this example up here. We have x squared over 4 minus y squared over 4 is equal to 1, which is what we're looking for. Now, is this open vertically or horizontally? It's open horizontally because the x is first. So our center is located at the origin. Okay, And then what we're going to do is we're going to take the square root of the two bottom numbers, and we're going to move that distance left, right, up, down. So the x, we're going to move left, right 2, because the square root of 4 is 2. And the y, we're going to take the square root of 4, which is 2, and we're going to go up, down 2. So now, once we have that, okay, so here, I've drawn my center. Here's where the two lines intersect. And then I've gone over 2, up 2, down 2. Okay? And what I've done is I've made a box. And once I've made that box, that's going to help guide my parabola, or my hyperbolas. This blue line is the asymptotes. Okay, so these blue lines are the asymptotes. And as you notice, they just go from corner to corner of our square. And once we go corner to corner from our square, that's going to help guide us as well. Now to draw this parabola, what you're going to do is, since you're opening horizontally, you're going to pick a point the middle of the horizontal parts. Okay, that's where your vertices are. And then all you're doing is you're just going to arc it, going in both directions, up and down, and you're going next to that asymptote, but you're not touching that asymptote, okay, and you're not crossing that asymptote. So you just want to approach the asymptote but not touch it, and there would be our parabola, or hyperbola. Hyperbola, okay? So that would be our hyperbolas. Okay, so now what if it's not centered at the origin? So if it's not centered at the origin, then we have HK, and if it's the HK, then we're just adding or subtracting whatever our number is that we have where our center is. It's not centered at 0, 0 now it's actually at a number, so we have to adjust that. So here's your formulas for if it's not centered at the origin. And this one is a vertical or horizontal. It's horizontal, again, because the x is first. You notice how the asymptotes are a little different because now they are using point slope formula. So you have your slope, and then you pick the point that was the center of the circle. Because if you look back, the asymptotes have to cross at the center. Okay, so that's why we use the point HK in our asymptotes. Okay, so here's what it would look like when we have our y first. So if the y is first, that means it's a vertical or horizontal. It's a vertical hyperbola. So it's a vertical hyperbola. Center again HK, but now you notice you're changing all the k values, not the h values. So if you are opening up and down, you're going to be changing all the y values, not the x values of these. And you notice the asymptote is the exact same formula. The number underneath the y goes on top, and the number underneath the x goes on bottom for your asymptotes. Okay, and then you have your point HK. Right. So that's your formula for your hyperbolas. Okay, so let's look at this example. So first off, what is the center of this? The center is -1, -3. Okay, because again the x is first, but in this case the y. So is this opening vertical or horizontal? This is opening vertical because the y is first. So that means when we deal with our vertices, that means that the y value is going to be changing. So our points are going to be -1 something. Okay, and what we would do is we take the square root of the number underneath the y. Square root of 4 is 2. So that means we're going to be adding and subtracting 2 to this number. So if we add 2 to it, we get -1. So we have a point -1, -1. If we subtract 2, we get -5. So we'd have our point -1, -5, and -1, -1 for those. Our foci is taking the two bottom numbers and adding them together, and then taking the square root. So we have the square root of 20, okay? And now we add and subtract that to our center, okay? So we add and subtract that to our center. And so we'd end up going -1, -3 plus 20, -1, -3 minus 20, which 20 can be written as 2 root 5. Okay, it's the same thing. But you notice that those foci, the y values are outside of, it's smaller than -5 and it's bigger than -1 because they end up in the circle. So the last thing is your asymptotes, okay? And with your asymptotes in this case are going to be y equals, you take the y value, So 2 over 4, okay, taking the square root, or 1/2, parenthesis, x plus 1 minus 3. That would be one asymptote, and the other asymptote would be negative 1/2 of x plus 1 minus 3. And again, your slope is based on the y's on top, the x's on bottom, okay, when you took the square root of them. And then you plug in the center into h and k in that previous equation. You have one positive, one negative. Okay, that's how you get your asymptote. Okay, so here's your homework for this section. Make sure you draw each graph. So you should have 6. And then we're good. That's what we do.